Welcome to this OST2 lecture about enrolling a remote system using a TPM 2.0. In this lecture, we'll use everything that we learned in the previous lecture so far in TC1102. The topic is complex, but we've tried to split it in several steps. Here is an overview of the typical workflow when enrolling a remote system using a TPM 2.0. Some of these steps might be familiar from the previous lectures in this course, but do not skip steps. Otherwise, the workflow and the enrollment will not be complete. Then we need to extract the public key and transfer it together with the EK certificate to a remote system for verification of our TPM. Then we need to generate a child key under that EK and transfer the key's name. The key's name is a digest of the attributes of the child key, in that it is also unique. That child key will be the machine identity we will use for that remote system. Why? Because the EK cannot perform signing operations. This is why we'll have a child key under the EK that can perform signing operations. The remote system will verify the TPM as genuine using the detailed procedure from the previous lecture. Now that the remote system has confidence in our system that the TPM is genuine, it will generate a credential, a challenge, using the child key's name and the EK pub. We'll look closer in this process in a moment. Then the local system with the TPM activates that credential using the EK private key, and then the local system has to prove to the remote system knowledge of this credential. If this is true, then we can be certain that our child key that we use for machine identity is unique. It came from the endorsement hierarchy under the EK of that TPM, and the TPM is also genuine. Using an EK for machine identity and making this onboarding remote enrollment process is complex. But there are only two steps. The first one is TPM2 make credential. And this step is pure cryptography. It's just mathematics. We can even perform TPM2 make credential without a TPM because it is just creating a challenge using a public key and encrypting that challenge. Then the activate credential command is more complex. And often you'll find developers who struggle with understanding the concept and the way it works. But in this lecture, we'll clarify everything. Now, as just mentioned, TPM2 make credential is just cryptography. It takes as input the name of the child key that we created, and I'll just call that an AK, which stands for attestation key, because we'll need it later when we get to attestation. And we encrypt the AK's name and a user arbitrary data challenge as credential using the EK pub. What this means is that only the private part of the EK on that TPM can decrypt this challenge. And remember, the EK can only perform encryption and decryption. It cannot perform signing operations. So this works great. And for that second important part of decrypting the challenge, we need to use the activate credential command, which performs the decryption using the EK private key. How the challenge is transferred between the two systems after a successful TPM2 activate credential is up to the developer. It can be using TLS, HTTPS, or SSH. It really depends on your needs and what you have available. The process is important. So far, we've covered how to generate the EK using eSAPI and using TPM2 tools. We then learned how to verify the TPM as genuine, and we know how to generate a child key under the EK. What remains is to make use of the TPM2 make credential to generate the challenge, and then make use of the TPM2 activate credential to decrypt that challenge and prove knowledge of it. Let's take a closer look at the eSAPI API for make credential. We have ESYS context as first argument, as usual, nothing special there. Then we have a handle pointing to the EK. This means the EK has to be generated and ready for use. Then we have the 3 authorization slots as usual, and we can add a session for protection against machine-in-the-middle attacks. Afterwards comes the credential, which is the arbitrary data that will be added to the challenge. And as part of the challenge, we have the name of the child key. The output is the credential blob. And for that, we just need to provide a pointer variable because it is Kali allocated. The makeCredential function will allocate the necessary memory to store the credential blob or the challenge. And the secret is actually the encrypted symmetric key used to protect the credential blob. The secret is encrypted using the EK pub. Here are the steps we need to make to prepare for use of makeCredential. Is create primary to generate the EK and load the public part of the EK. Of course, we need to provide the EK policy to satisfy and authorize the EK for use. Then we need to generate a child key under that EK. Once we have that, we can use the isis_tier_getName API using the child key to acquire that child key's name, or also, as we say, AK name. Last but not least, we need to acquire the EK certificate for verification of the TPM genuinity. We transfer all of these artifacts to a remote system that will serve as a verifier. And here is the typical flow of using makeCredential. We perform sysinitialize to configure our TCTI and the TPM. We load the external public key. We make sure to have the EK name also ready. And then we prepare our own user arbitrary data for the challenge. Then we can safely invoke sys_makeCredential, and this will produce a credential blob and secret that we need to transfer to the other system in order to verify it. What can be used as credential is limited by the TPM2B digest format, and usually this is 1024 bytes. But of course, the recommendation is to use just random data and maybe even get it from the TPM itself using the isis_getRandom API that will invoke the TPM2getRandom command. So in order to verify the challenge later, make sure to store whatever data you generated and use this challenge during the makeCredential process. The transport layer in modern times seems to be a problem mostly for battery-powered devices, since today we have a lot of wireless connectivity options. At the same time, remember that the bigger the challenge you set in makeCredential, the longer it would take to transfer. And I think this matters especially for IoT systems. Now that we have transferred the credential blob and the secret to the other system, we can use isis_activate_credential to decrypt the challenge. First, we need our ISIS context set. Then we need to have the child key loaded and ready for use. Also, the EK loaded and ready for use. Then we have the 3 authorization slots, as usual, that we can use for a session with protection against machine-in-the-middle attacks. Then we are providing the credential blob and the secret. And as a result, we'll receive insert info, which is just a TPM2B digest, the challenge that the remote system provided. This is just a pointer variable because it is Kali allocated. It will be allocated by the activate credential with the size that is required to store the challenge. Once the challenge is decrypted successfully, we have to transfer that to the other system to prove knowledge of that challenge. The typical flow for ISIS activate credential involves making sure we have our ISIS context initialized and set with the proper TCTI to talk to our TPM, then create primary to recreate the EK, make sure we satisfy the EK policy, then make sure we have our child key recreate or loaded depending on your preference, and invoke activate credential using the credential blob and secret generated by makeCredential. Once we have the resulting challenge, we need to prove knowledge of that to the remote system. In order to perform the labs for this lecture, I strongly recommend to use your solutions from the previous labs in lecture D, where we generate an EK and we generate a child key under the EK. Then add makeCredential to generate the challenge, and immediately after add activate credential. This way you skip using a transport layer to transfer artifacts and files and information. The purpose and goal of these labs is to help you understand the process and perform it when you need it. This is why I recommend having makeCredential and activate credential in the same TPM application for learning purposes.